Today we'll be taking a look at Altair AI Studio, previously known as Altair RapidMiner. You may still hear this tool referred to as RapidMiner, as AI Studio is within the umbrella term RapidMiner. AI Studio is Altair's answer to no-code or low-code machine learning. With that, we can import, clean up, prepare data, and actually train models, and then we can implement them directly on new unseen data. So when you first open AI Studio, what you'll see is this welcome screen right here, where we have plenty of templates to begin your modeling in the software. So this is things where you can predict if your customers will churn, identify outliers, which could help you find irregularities in financial data or even in engineering data. We can do sentiment analysis where we can see if, for example, customer reviews are positive or negative. We can look at predictive maintenance, so without having to do a complete engineering model of some sort of system or device or assembly, we can look at other measured data from existing real-world examples to predict how long these systems might go before they need to be replaced or repaired. And there are several other examples. There are also built-in learning modules directly within the tool. So what these will do is it will kind of hold your hand as you walk through the process of learning the different aspects of the software. So by that I mean it will give you some instructions and some detailed examples about what blocks are doing, what operators are doing, how to start to build models, and it will also then check to make sure that you've plugged everything in correctly from there. So that way you can get quickly up to speed with how the tool works. So for today's example, we're going to start from scratch actually. So we're just going to stay right here. And before we jump into it, I do want to talk about just a couple of the things that you see right when you open the window. So first we have this process builder space. This is where you will actually drag and drop your operators and your data and begin to plug things together to complete whatever goal it is you're trying to accomplish. And so what do I mean by plugging in your data and plugging in your operators? Well, that's what we see over here. So up in the top left we have the repository, which is where we can see some of the data provided in RapidMiner for training and for examples, but then also we can look at any data that we have saved ourselves, and that includes connections to external databases. So that could be something hosted online. You can connect to an Amazon server, you can connect to your Salesforce instance or other CRMs, or you can save it all locally within your instance of RapidMiner. Whatever's most convenient for you and your team. And then by operators, I mean these blocks down here. So this is where you're actually telling your process, your model, what you want to do in a step-by-step basis. So in this case, we might want to retrieve our data first, and then we might want to go on to normalize one aspect of that data. And to do that, we would just put these blocks in, connect them, define a couple parameters, and then connect this to our output, and then we would have a process. We'll be doing something a little bit more involved than that today, but just as kind of an overview of what the different pieces are. Now over here we also have a help panel in the bottom right. So whenever we add a new block to a model, let's grab this normalize again, it will give you the help documentation for that block right there. So it gives you a description, um, what some of the different options are, what the different parameters of it are, and how you can set it up. And then you also typically have an example or a tutorial linked down here at the bottom. So if we were to click this, it would open up an example for us, showing us how to use this block and actually what it does to the data we're using it on. And when I say that there are parameters that we can fine tune and edit, we actually can edit those up here in the parameters panel. Uh, One last thing I want to point out in general, before we kind of look at a more specific example, is when we see this green arrow right here next to a parameter that we can change, that means it's using the wisdom of the crowds. So by that, what I mean is it uses historical trend data from other AI Studio users to see what most other people are doing when they are executing a similar process. And, you know, maybe not always the best method of normalization is Z-transformation, but 70% of the time that's what users are keeping. But then we also see, okay, a lot of people are using range transformation. Maybe we should give that a try. And you'll see that a lot on several of the different blocks or operators with their parameters. Not every parameter has this, but a lot of them do, and it's a great way to kind of push you in the right direction if you're new to data science or if you're new to manipulating data with some of the tools available within AI Studio. So now we're going to take a look at retrieving data and actually using it in our model. So there are several different ways. As I mentioned, we can connect to some databases. We can use some of the data that's already in our RapidMiner instance. But what we're going to do is we're going to assume that we have an Excel file with the data we want in it. So we have a couple options. We can just start with the read Excel, or if it's just a normal CSV, we can do that. But I'm going to begin with open file because this, it might not be in CSV or Excel format, but we'll start with open file, and we'll plug in the file name that we want to open. So in this case, we are grabbing some sonar data, and I'll explain more what that is shortly once we actually see what it looks like. So now we're retrieving that file, and let's go ahead and read it as an Excel file, and let's plug it in over here so we can see what we're reading. So now if I click run, what we'll see is a big spreadsheet almost. So in this case, this is actually our data set or our set of examples. So by that, each example is a row in this spreadsheet, and we also see that we have attributes. That would be the columns in this spreadsheet, and the attributes are just the descriptors of each entry or example in this data set. So what we see here are sonar scans of various objects underwater. Some of them are rocks, and then if we scroll down, we'll see that some of them are mines. And we want to be able to use the sonar data to predict if we are looking at a rock or at a mine. So you'll see we have attribute 1, 2, so on, all the way up to attribute 60. So these are just different aspect angles of our sonar scan, telling us kind of what we're looking at in our point map, in our sonar point map. Now it's not too important to know exactly how sonar functions to understand what we're doing with the tool here. Basically, we have we're sending out some signal and getting these 60 numbers back, and in some of the cases we're pointing at a rock, and in some of the cases we're pointing at a mine. That's what's most important. And we want to know if we can use just this information, this sensor information, without knowing if we're looking at a rock or a mine, if we can accurately predict which one it is. So that's one way to pull this information directly into RapidMiner. There are a couple other ways. Say you want to use a bigger set of data that is only available on the internet. So we can actually add an extension to our AI Studio interface where we can do some web mining. So these extensions are basically little plug-in apps that you can use to add to the capabilities of AI Studio. And really popular one here is the web mining capability. So what we can do here is actually we can crawl the web or get individual specific pages. So what these operators mean, I'll just drag them out here. We won't actually use them for this example, but let's say we wanted to just get information from one web page. We could use the get page, plug in its URL, and then we would get whatever information is publicly available for that page. So that will typically look like the HTML output of that page. So the website code used to define what you see. So that will include not only the information displayed to the user on the page, but also a lot of information about the structure of the page. So depending on what you're doing, the structure may not be the important part. You may just want the presented information, but that is up to you, because then you could process that information however you see fit to get only the pieces of information that you need for your application. Similarly, get pages, we could give it a list of URLs, and it would basically repeat the process and repeat a collection repeat the process over the collection of inputs and provide a collection of scanned pages as the output. Again, it would look the same as the get page. We would just have several results. Now let's say we know where we want to start for our data, but we don't necessarily know the URL for each individual page we want to look at. That's where crawl web comes in really handy. So crawl web basically allows you to provide a starting URL, a starting web page, and then you can provide crawling rules. So say you know that every single page you're looking at has a certain similarity in the URL. For example, that could be you want to look at the prices of cars on a dealership's website. Maybe the dealership you're looking at, every single page that actually has a car on it will have the word car in the URL. So you could set that up as a crawling rule to say, hey, only go get those pages that have this criteria, and then give me those results. And we can also specify max crawl depth, which is basically how many pages away from the starting page are you willing to scan this information. So are you just trying to get, those first button clicks off of the main page, or are you trying to get to a secondary or tertiary button click from there? So clicking on one link and then another and then another and then getting that page's information. You can define that depth right here and define how you want to retrieve all this information. And this can go on for a while, or you can set some caps here so that way you don't bombard the website or violate any terms of service, and you also don't wait forever getting every possible page by accident. But again, those are just some of the options, additional options for getting data. We're going to stick with pulling in directly from Excel and looking at what we can do from there. So now let's say we've pulled in our data and we want to clean it up a little bit. So one thing we can do to make this process a little bit easier is we can actually store this data we've just pulled in right here, and we can define repository entry to actually save this Excel spreadsheet within AI Studio, so that way we don't have to pull up Excel every single time we want to access this data. So we'll just assume that in this block right here that I've plugged in that it is the sonar data, but we can see that we already have it saved right here, but we could assume that we had actually typed that in right here and saved it wherever we needed to. So to actually clean up the data, we're going to move over to Turbo Prep. What this will do is it will allow us to prepare, reorganize, and set up our data for machine learning implementation. So I'm going to grab the sonar data right here. And again, it will look very similar to what we've seen before. We have all 60 of our attributes and then our class, which will eventually become a special attribute or our label for the data. So there's not much that needs to be done to the data set we have right here, considering that this is actually already a fairly clean and complete data set. But we can walk through a couple of the options of what it might look like to actually use Turbo Prep on perhaps less cleaned up data. So first we have this transform option. So we can go through and select some of our different attributes. So let's start with class. So we can actually say if we want to rename this or if we want to change it to a different type of variable. We can outright remove it, copy it. We can filter all of the examples based on this. So say we only want the examples that are rock, we could do that and we would get rid of all of the mine examples from our data set. We can also randomly sample and sort or replace any of the entries or examples based on this attribute. So again, a lot of options here to start to get the data in the structure that you want, and make sure that we're not missing any data and we have data that makes sense in our model. So we also have the cleanse option. So similarly, we can select an attribute and we can do some auto cleansing, which will just run through a couple of predetermined processes to do what AI Studio thinks is the best to clean up your data. But we can also remove low quality data or highly correlated data. We can also normalize or discretize the data, again, depending on what we need. So say we have as our output, in this case it is binomial, we just have rock and mine, but assume that we had a continuous range of outputs, assume numbers for example, and we wanted to discretize it into more of a categorical model. We could do that. Or if our numbers varied wildly from a very large negative number to a very large positive number, that a lot of times can cause calculation issues in several different kinds of models. So we could normalize that to example with a range from -1 to +1 or just from 0 to +1, however we see fit. We could also remove duplicates if we needed to. Again, there aren't any duplicates in this data set, but a lot of options here to get rid of data that we don't need. Next, we can also generate new attributes. So this would give us a formula editor. So again, this is just a different way to add more information to the data. So say for example, you wanted to, for whatever reason, add a new attribute that is the product of attribute 1 and attribute 2. We could do that. We could add a new column or new attribute. We'll call it product 1, 2. And then we could go down to the formula and we could say, let's do attribute 1 times attribute 2. And then we could update the preview and we'll see we have this. So these are some small numbers. So we're going to get very small numbers for this one right here. Again, in this one, It's not very useful, but this could be used to create a highly customized addition to your data, and that includes several different logical, mathematical, and text-based functions that you can add to manipulate the data you have on hand into a more usable format. So we'll cancel this. Uh, Next, we can pivot the data how we need to. So we can drag our attributes to pivot. Again, this won't show us too much in this case um, because this data isn't really structured for pivoting. But if you had a different data set and wanted to generate a pivot table, you could. Lastly, we can merge. So if we had another set of scans of rocks and mines, or even of other classes, and we wanted to add it to this model to either improve its prediction capabilities or expand the categories for which it can predict, we could add those data sets here, and then we could also go back through and clean up the merged data set if we needed to. So that is everything that we can do with the turbo prep. So that gets us from our raw structured data to a more refined, more model ready data set that we can actually begin to make predictive models with. Now, the first place that you can start to build a predictive model with very little experience in machine learning is to use the Auto Model tab. So from here, we can select the data we want to use, and then again, we'll load it, a preview, so we can make sure we're looking at the right data set. And we have a couple of options of models that we can automatically generate. In this case, we'll want to make a prediction model to predict if it's rock or a mine, but we can also generate clusters if we wanted to take a more unsupervised approach to our machine learning, or we can identify any outliers in our data. So the clustering and outlier isn't necessarily what we want to do for this specific example. We are interested in predictions, specifically this class of rock or mine. So we'll set that up, and then we'll go to the next one where we can prepare our target. So what we'll do here is we can see that we have two categories that we're going to be predicting, and we can define our costs and benefits of these categories. So again, we'll leave these as default, but let's say we wanted to more thoroughly reward the model for accurately predicting a mine and more harshly punish it for predicting a rock when it was actually a mine. We could adjust these weights, these biases right here, to kind of fine-tune the model to lean in the direction that we need it to lean. We can also say that the mine is the class of the higher interest right here, and if we wanted to, we could rename these, but again, they're pretty self-explanatory right now, so we'll just keep them as mine and rock. Now we can select the inputs to our model. So what this will do is it will display all of the different attributes that you have added, except for the labels, you have added to your model, and it will give you kind of a high-level overview of what each attribute looks like. So it shows the correlation of each model, the ID-ness, the stability, what percent are missing, and how much an attribute consists of text. If you want more information about how these values are generated, we have this info pane right here that will break down a little bit more about how it's generating these measurements and what it considers to be a good or bad quality attribute. So in this case, we can see that we have some lower quality, these yellows, and then one poor quality attribute, which is most likely due to the high stability, the relatively high stability of these attributes compared to the other ones. So this is where you, as a data scientist, uh, could make the decision to say, hey, no, I know more about my data than this stability measurement is providing, so I do want to include it. Or this is where you say, if you are not a data scientist, that if you're not sure and you want to listen to the suggestions, we can deselect the red and yellow and say, let's only go with the high quality attributes for our auto-trained models. So let's just assume that we know that we want all of these attributes, so we'll select all and go from here. So the last step before we can actually train and compare the results is to select the different kinds of models we want to use. So we have several options, including a naive Bayes model, a generalized linear model, logistic regression, deep learning, and a couple different kinds of trees and forests, as well as a support vector machine. And we can apply some customizations to a couple of these options. For example, we can apply a maximal depth to our decision tree, or we can automatically optimize different models or leave them or decide our own constraints. So we don't need any of these over here, but again, this is just where we could clean up the data as we're using it. We could extract any text or date information that isn't necessarily useful to specific types of models. So now we'll go ahead and run these models, and this will only take a moment since this is a relatively small data set. But what we're seeing here on our overview is the classification error in this plot on the left. This is the classification error for each of the different models we're training. And then over here on the right, we have the actual time it takes to train and score these models. So again, this could be helpful if you are interested in knowing how long it would take to potentially retrain these models in the future with new data, or how long it would take to implement this model and actually score some unlabeled information. So say we have built and trained one of these models and we want the fastest prediction possible, then we would look for the lowest option right here, which right now it looks like the decision tree is our fastest trained and our fastest scoring. And we can see that the gradient boosted trees had the lowest level of error, of classification error. So we can take a deeper look at some of these models, not just overall error and speed. We can actually open up one of them. So let's go down to our gradient boosted trees and take a look at our model. So we can actually see the trees and how the decisions are being made. We have the weights for each attribute. We can also simulate a new input. So this could be where we would go through and apply all of the values for the attributes. This simulator is a little bit more helpful if you have a smaller set of attributes, but you still technically could go in and actually slide these up and down to see what it predicts. We can also analyze the performance of our model, so we can see that of its predictions of rocks and mines versus the total true amounts of rocks and mines, and we can see that this model did actually do fairly well when it comes to our accuracy and classification. We can also look at our lift chart to see that this is better than just guessing. And then we have a couple other things, including the optimal parameters of the model, the specific predictions for each entry, and how each attribute played a role in that prediction, as well as the confidence of each prediction one way or the other. And then lastly, a model that we can export to production. And we have the similar options for all of these different models that we've generated over the course of this auto model. So the last thing I want to show before kind of jumping into a custom design is the interactive analysis tab. So again, what this will do is it allows us to generate a tree interactively, a decision tree, and we can see how our inputs are changing its structure as we go. So again, we want to classify based on rock or mine. We can determine which attributes are used, similar to the auto model, how we want to, which split search method we want to use, and also how we want to measure the performance. So we'll just keep everything default for right now. And then we also have our auto grow and tree settings, so we can automatically grow the tree and then determine the p-value or maximum branches. We can determine max bins if we want to use missing values. We can set parameters for continuous columns and ordinal columns as well. So there's a lot of customization settings here. And then we can hit create, and we'll see our decision tree come out right here. So this isn't the example that we'll be running through momentarily, but again, we can just see kind of what the options are here. We can auto grow the tree from right here if we wanted to see how that would change the performance. So for the last portion of this, I want to jump back over to the design panel. We will now take a look at building a model from scratch within our process designer page of Altair AI Studio. So earlier we went through the process of how we would collect and clean up and store that data. We'll assume we've done all of that and we have all of our data ready to go. So in this case, I'll just delete that and just pop the data right here within our model. So one thing that we need to do is to actually tell this model that we want to label either that mine or rock class as our binomial classification for this model. So we can go down to our operators and we can actually just search for the one we want. So again, we can look at all of the different options for what we're doing, and we want to convert this column, this class, from nominal to binomial. So we'll just grab the nominal to binomial and we can click and drop it right here, and then you see how it automatically connects that for us. So this little bubble is red. This node is telling us what kind of data it's expecting and what kind of data we're outputting on the other side. And if we want more information, we can hover over it and press F3 on our keyboard to get more information about what it's talking about. So in this case, it's upset with us because we have not told it which attribute we want to convert to binomial. So we don't want to convert all of them. We just want to convert a single one, and in this case, it'll be the class. And we'll need to go ahead and check include special attributes because this is a special attribute based on how this data was previously stored. So again, we'll run and we'll see that nothing has really changed except in the statistics. Our class now is listed as binomial. Again, we can kind of look at all of this data before even fleshing out our model. We can look at the distributions of each attribute, each input to this model right here. We can see the minimum and maximum as well as the average and standard deviation, and we can even open up a visualization of this data right here to see what we're looking at. We could do the same thing for our classes, but we only have the two and they are roughly the same size. They're off by a little bit, but that's okay for our purposes. So we'll go back over here to the design tab, and now we'll get ready to actually start building our model. So we first need to split the data for training and for testing. So we can just grab a split data operator and also just plug it right in. And if we find ourselves getting too close over here, or we want to just reorganize, we can always move these around and the connections will stay the same, and we can make this easier to read as we see fit. We can even add a note detailing what's going on somewhere. Let's go to our split data, and we want to do the traditional classic split of 70% or 0.7 and 30% or 0.3, and we'll click OK. So now the two outputs of here, these PARs, are actually our partitions, our par 1 and par 2. So we can see the number of examples in each one. For the 70% we have 146, and for the 30% we have 62. So now we can take that 70%, the partition 1, and use it to train a model. So let's say we really want to use some form of neural network in this case. We can see we have a couple of different options right off the bat. We can just go and grab this deep learning and plug it right in. Before we go any further on that, I will just show all of the options we have for predictive modeling. We have our lazy models like KNN. Then we also have some Bayesian models, different trees or rule induction models, as well as neural networks, creating functions, support vector machines, etc. So there's a lot of options here to generate predictive models, or any kind of model for that matter. Next, what we can do is customize our deep learning block. So what we can do here is all of this that normally take lines of code in, say, Python or another language you might be using, you can just do from a nice, easy to read menu right here, where you can define your activation function, and you can see what other users are selecting with the wisdom of the crowds. We also have the learning rate, our epsilon and rho of our model, our loss function. We can decide at number of epochs that we want to train this model. So there's plenty of customization here to make this truly your individual, your customized model to fit your specific needs. And so now what we want to do is we actually want to see how this model does. We don't want it, for at least not yet, to just spit out this model. So what we can do is go back over here to our apply model, and we'll take this right here. So we'll take the second partition down here to this UNL, that's for unlabeled data. And then this model, instead of connecting to the output, we're going to put it right here. So we're going to take the model we just trained and apply it to the unlabeled data that we split earlier. So we could just take a look at what the labels are, but we also want to get a look at the analysis of the performance. So we have several different performance metrics for our predictive models. In this one, it's binomial classification. So we'll just grab that block, put the label right there, and then we can look at the performance and the labeled examples as the output. So we'll go ahead and train our new custom model right here. And we'll see now we have all of our unlabeled data, originally unlabeled, with the predictions of our trained model, as well as the confidence of those predictions. And we can also compare it to the true class to see if we're correct. To get a more high-level overview, we can look at the performance of the model to look at the number of predictions for each category compared to the amount that was truly in each category. So in this case, you can see this model does a fairly good job at identifying rocks versus mines. I'm sure there's some more work we could do to improve how well this model is doing. We could also take a look at how the different attributes are having an impact on the classification. So let's say for one final thing, we want to try to improve this model with cross-validation. So we can actually do that. We'll take the cross-validation block, and we are going to end up changing a little bit of what we do up here. So what I'm going to do is actually highlight all of this. I'm going to right click and disable them. So this way they're not deleted from the model in case we want to use them later, but they aren't going to do anything right now. So what we can do is take this data that we've set up, plug it into our cross-validation block, and we'll double click to go inside. So this is where we can set up our training. So again, let's grab our deep learning and we'll plug that in right here. And we need to output our model in this case. So then again, for our cross-validation, we need to apply the model for the testing. So we'll say the model, in this case, the unlabeled data is the test data. And we want to take a look at the performance of this. This is part of cross-validation. So we'll do binomial classification. We'll plug that in right there. Okay, so then we can go back up to our main process and we can look at our model. We can look at the performance of our new cross-validation model as well as the results from the examples. And we'll train this and we'll take a look and we'll see that it had some effect on the overall accuracy of the model. Nothing too significant in one direction or another, but we could use this to make more informed decisions about how to update our cross-validation or to update the actual training and testing within the model. So we've kind of gone over the several different options available to go from importing your data from various sources, cleaning up your data and preparing it for implementation in some kind of model, actually generating those models automatically with some interactivity, or completely from scratch by yourself, completely customized however you see fit. And we've seen how to analyze those results, how to come back to our model and make changes as we need to get an end result out of AI Studio that helps us make the best decisions possible based on the data we have available. If you have any questions about AI Studio or the RapidMiner umbrella software or any of the Altair tools available, please do not hesitate to reach out to us at trueinsight.io. On our website there, you can contact us with any questions about this software, other data software, or any simulation software we offer. You can also check out our blog there, where we write about different applications, different technical aspects, or fun examples of the software. And be sure to also check out our YouTube page. Subscribe if you're not already subscribed to get updates on videos like this and other projects related to the Altair suite of software. Thank you for watching and have a great day.